Welcome to Jarnac Tutorial 4, Modeling True Bistable Systems. Bistable switches are commonly found as network motifs in prokaryotes and sometimes in eukaryotes. They represent the biochemical equivalent of a light toggle switch. In this tutorial, we will introduce a bistable model and illustrate its unique switching properties, as well as introducing the notion of a free format rate law. We will start with a model partially entered into Jarnac. We will have a pathway P, two fixed variables x0 and x1, and a floating variable s1. The model we will be entering illustrates a simple regulatory loop from S1 to V1. The regulation is positive in the sense that when the concentration of S1 increases, the rate through V1 increases. Since there is not a built-in rate law with this property, we will instead enter a free format rate law. Our first reaction involves x0 and S1. The complicated rate law indicates that S1 acts as an activator, stimulating its own production. Our second reaction between S1 and X1 will be an irreversible mass action rate law. We will initialize our species concentrations to 0.12 for x0, 0.1 for s1, and 0 for x1. We will initialize our k0 value to 12. We will then add our familiar time course simulation code and run the simulation to produce a graph. Notice that the system approaches a steady state with a value of roughly 1, nothing out of the ordinary. Let us now change the initial concentration of s1 to 4 and carry out the same simulation. After creating our graph, we'll have to edit the axes. Click on the Edit Chart button, select Axes, and change the minimum y-axis value to 0 and the maximum y-axis to 10. Then close this window. What is unusual is that the model has clearly settled to a different steady state, a high steady state compared to the first run. You can return the initial concentration of S1 back to 0.1 and run it again, and you will see that the system's settled to the lower steady state. This concludes Jarnac Tutorial 4. In Tutorial 5, we'll investigate reaction stoichiometry and oscillators.